So hey guys, this is Dipesh, and in this particular video we will be implementing k-means clustering, and I will show you how we can implement using both elbow method and with even without elbow method. Okay, so let's get started. So the first thing that you should do is download the dataset. So just go on Google and write mall customers dataset. Okay, just write mall customers dataset and just click the first link that you will find here. Okay, so this link will take you to kaggle.com. Now all you have to do is just download this dataset. Okay, just download this dataset. Now this dataset is basically the same dataset which we basically used in our previous video as an example. So it consists of variables like age, annual income, spending score. Basically it is a dataset of customers in a mall. Okay, all right. So once you have downloaded this, the next step would be implementing the algorithm here. So let's get started. First thing that we'll do is we'll import some necessary libraries. So let's import NumPy. Let's import matplotlib because we'll be creating scatter plots to visualize our clusters, and also import pandas to read our downloaded dataset. And the next thing that we have to import is the k-means algorithm from scikit-learn. So what we'll do is we'll do from scikit-learn dot cluster import k-means. All right. Okay, let's execute it, and also let me create some extra cells here. Alright, so the next thing is just go onto your local machine where you have kept the downloaded dataset and copy its path. Okay, let me just go and copy the path on my machine. Okay, so once you have copied the path of your dataset, now let's read this dataset. So what we'll do is we'll do df is equal to pd.read csv. Since it's a csv file, we'll be what we'll do is we'll do read csv, and then just pass the path of your dataset and also print the first 10 rows of the dataset. So let's run it. Okay. You can see that we have in total 5 columns. Okay, but we won't be using all these 5 columns because what we want to do is we also want to visualize the clusters. So if you go beyond two dimensions, it becomes very difficult to visualize the clusters. Okay, so we'll use only 2 variables here. We'll use age and we'll use spending score. Okay, so also let's change the name of this spending score column. Okay, uh, let's change it to something more readable. So what I will do is I will do df dot rename, and df dot rename basically takes one parameter called as columns, which is again basically a dictionary where the value is where the key value is the current value, current name of the column. Let's pass this, and then the value of this dictionary would be the new name of our column. So let's name it something like spending score. Okay, now let's again visualize our data set. Yeah, one thing I forgot to mention here is we also have to do in place is equal to true. Okay, now again let's run it. Now you will see that the name of the column has changed. So we have two variables, age and spending scroll. So let's drop the other columns here. So we'll do df is equal to df, and we pass this as age, and another variable is spending score. Now let's print this data set. Alright, then now this data set would be our x value here. Okay, now since we are not trying to predict anything, there is no y variable here. Okay, so yeah, now the next thing that we have to do is we have to basically create the model, and we create the model and train the k-means model on this data set. So what I will do is I will do model is equal to k-means, and one important parameter that this function takes is n clusters. Now what this n cluster is basically the value of k. N clusters is equal to, let's say, 3. So n clusters is basically the value of k. So let's just for the sake of implementing this, let's keep it k is equal to 3. Okay, so the next thing that we'll do is we'll do model dot fit, and we'll pass it our entire data set. Okay, now this will train our k-means model. Okay, now our model has been trained. Now the next thing that we want to do is we want to basically predict the not predict, but what we actually want is we want the labels of this data points. Now when we basically train our k-means model, what k-means model basically does is it basically creates k clusters. Okay, now here our k is 3. So during training it would have created 3 clusters in our data set, and it would have assigned labels to each data point. Okay, so what we want is we want the cluster labels. So what we'll do is we'll do cluster labels, and we'll do model dot predict. Okay, so model dot predict will basically contain the cluster labels. So let's print the values. Okay, it's asking again for the x value. So let's give it the x value again. Now let's see. Okay, so here you can see again that it has predicted labels here. Now you can see that there are 3 unique values here. So there is 0, there is 1, and then there is 2. Okay, so there are 3 unique values, which indicates that there are 3 clusters in our data set. Alright, since we gave k is equal to 3, it has assigned it has used 3 labels to define the clusters. So let's what we'll do is we'll join these values to our original data set. So what we'll do is we'll do df is equal to what we'll do is we'll do df and create a new column and assign it the values of cluster labels. Now let's print our data set. Okay, so as you can see, now now we have successfully attached the cluster labels here. Now what this column indicates is it says that the first row belongs to the 0th cluster. Okay, while the second row basically belongs to the cluster with belongs to a third cluster. Okay, so now the best way I can explain this to you is by visualization. Okay, so what we'll do is we'll create a scatter plot now. So let's create a scatter plot. So what we'll do is we will simply do plt dot scatter, and the x will be age, the y would be our spending score, and another useful variable that will help us recognize the clusters is c. Okay, c will basically takes the labels. Okay, so what we'll do is we'll do df and we'll pass it cluster. Okay, now let's visualize it. Okay, so as you can see here, the model has, since we gave k is equal to 3 here, since we gave n clusters is equal to 3, the model basically detected, basically created 3 clusters here, detected 3 clusters in our data set. Okay, now if I change this value, if I change this value from, let's say, 3 to 5, okay, now the k value is 5. Now if I run this again, now you will see that the model has now detected 5 clusters now. Okay, so in this way, basically for different values of k, the model detects k clusters in our data set. Okay, now the next thing that we'll do is we'll try to find the most optimal value for k using elbow method. Okay, so let me create some new cells again. Okay, now also let me give it the heading. K means using elbow method. Now elbow method is not that hard. All we have to do is we have to create multiple models with different values of k. So what I will do is I will copy the path again, and I will again try to read the data set. Let's run it, and again the next thing that we'll do is we'll again rename our data set. Okay, so now previously what we did was, previously we created only one model. So now what we'll do is we'll create multiple k-means model, and we'll calculate their sum of squared error. Okay, so what I will do is I will firstly I will define the different values of k. So k values is equal to a list, and this list will contain different values of k. So let's do it for 2, 3, 4, 5, 6, 7, 8 and 9. Okay, so we'll create 8 different models with different values of k. Okay, so what the next thing we'll do is we'll create another list for maintaining our squared error. Okay, now let's implement 8 different models. So how will we do it? It's very easy. All we have to do is just run a for loop. So for k in k values, we'll do model is equal to k means, and we'll pass the value of k to k. Okay, and then next step we'll do is we'll do model dot fit. Okay, we won't do fit and predict because we are not training the model to visualize our data set or find the clusters. Now the main reason why we are training this multiple models is to find the most optimal value of k. Now once we know what is the most optimal value of k for our data set, we'll again train a single model, and then we'll try to again visualize this data set, visualize our clusters. So what I'll do is I'll do model.fit, and I'll pass our entire data set here. So once our model is trained, what we need is we need to find the sum of squared error here. Okay, which is very easy. The scikit-learn already provides us a very useful method. So what we'll do is we'll simply do SSC dot append, and again what we'll do is we'll do model dot inertia. Now this inertia, model dot inertia, will basically return the sum of squared error for the current model. Okay, and then we'll insert this error value, squared error value, in our list. Okay, so also once the training of all eight models is done, also let's print the sum of squared error. Okay, so let's run this. Okay, we are getting some error here. Could not convert string to float. Let's see. Oh yeah, we forgot to drop the we forgot to drop some columns here. So what we'll do is we'll keep only age and spending score, and we'll drop the rest of it. So let's do df is equal to df, and we'll do age and spending score. Alright, let's also visualize this again. Okay, so now we have dropped all the unnecessary columns. Now let's create the now let's train this multiple k-means models. Okay, as you can see, previously our list was empty. Our list for SSE was empty. Now after training multiple models, this list contains squared error values for multiple k-means models. Okay, so now what we have to do is we have to create a elbow plot, which is very simple. Again, all you have to do is just do plt dot plot, and on the x-axis we will keep k values, and on the y-axis we will keep SSE. Okay, also let me do some add some labels for the axis here. So on the x-axis we have k, and on the y-axis we have SSE. Now let's plot this. Let's display this graph. Okay, so here you can see that on the y-axis we have the squared error, and on the x-axis we have the k values. So as you can see that as we increase the number of clusters for our model, our squared error reduces drastically. Okay, so now the main reason why we implemented elbow method was to find the most optimal value for our k. Now and the most optimal value for our k is basically find that find the most optimal value for k at the elbow point. Okay, so as you can see, this value this region is what we call as elbow plot. So whatever value for x would be present at this region, we'll choose that value as our optimal k. So here you can see that the optimal value for k is 4. So then what we'll do is we'll basically train another model where k is equal to 4. So let me just copy this. Okay, so what I will do is now I will create another model, and now since we know the most optimal value for k, we'll train a new model for that k. Let's run it. Okay, now our model is trained. Now all you have to do is visualize the model. So let me again copy this, and what we'll do is we'll now visualize our clusters. Okay, let me also create, we also forget to predict the clusters here. Okay, so what we'll do is we'll just simply copy this, and And once the model has been trained, we'll predict the clusters here, and we will basically add this cluster column to our original data set. Okay, this is exactly what we did previously. Okay, let's run this. Now you can see that the model has clearly detected 4 clusters here. All right, and even visually we can even by looking at this data visually, we can say that yeah, the model basically detected the clusters very perfectly. Okay, so yeah, this is basically how we implement k-means algorithm using elbow method. In our upcoming videos, we'll be talking about some other algorithms which will be based entirely on this idea of k-means clustering. Okay.